Welcome to qnawire.
In this question, we are given a system of pulley and blocks. The mass of this lower block is given as capital M, and the mass of this block on the surface is given as 2m. There are three parts of this question. We have to find in the first part the acceleration of this M block. In second part, we have to find the tension force in the string, and in the third part we have to find what is the force exerted by this clamp on this pulley. As this end of the string, let's say this end is A and this end is B, so A and end A is at rest. If let's say mass M is having an acceleration of A, let's say downward, then this end point B also will have the same acceleration A, but in the forward direction. Okay, then if this pulley is, let's say, P pulley, then I can write the acceleration of pulley P, acceleration of pulley P, I can write this as AP, that according to the vectorial it will be AA plus AB divided by 2, and as we can see that end A is at rest and B will be moving with acceleration A, so we can write the acceleration of the pulley P is A by 2. So this is also same as the acceleration of 2m mass, so I can write then acceleration of 2m mass is A by 2, and that of m mass is A. If let's say the tension force on this string is T, let's say, so then this will be T. So then on the pulley P, the tension force will be T and T forward. So on the second string over here, the tension force will be 2T. So on this 2m block, the tension force will be 2T forward. So if I write the FBD for the second block, then I can write FBD for second block. Which one is second block? This one is second block of mass 2m, of 2m mass. As the second block is having acceleration of A by 2, so then I can write that the net force on second block is 2T, that has to be equals to mass, which is 2m into A by 2, and this imply that T equals m A by 2. So let's say this is my equation number 1. By drawing free body diagram for M mass, FBD for M mass will give us that net force is downward, which is of course mg will be acting downward, so mg minus t is equals m into A, and so from here I can write then, okay, from 1 I can write then that ma is going to be equal to 2t. So I can write then mg minus t is equals 2t, or t will be equal to mg by 3. This is the tension force on the string. This is the tension force on the string. So this is the answer for part B. This is the answer for part B. Okay, now from 1 I can write, from 1 we can write that t, in place of t, what I will write, mg by 3, that is equal to ma by 2, which imply that acceleration of this is going to be 2 by 3g. So this is the answer for part A, that is the acceleration of M block, right? So this is the answer for part A, 2 by 3 g. For part C, here you can see that on this string the tension force on the pulley is the fixed pulley is towards left, that is T, and downward also the force is T uh, uh, on the fixed pulley. So then the net force on this pulley, we can write the net force on this pulley due to these two tension force will be acting in this way, that is the F net. Okay, so F net we can write as square root of T square plus T square, which will be root 2 T. So if this is the net force by the string on the pulley, so then we can say that force on fixed pulley by clamp, that will be also same. So which will be F net, which will be root 2 times T, and we already got the value of T in part B, which is mg by 3. So this is going to be root 2 times mg by 3, and that force will be acting in the opposite direction of this. So this is the F net. Again, this F net is basically the force on the pulley by the clamp. Okay, so which is root 2 mg by 3. So this is the answer for third part of this question.